Alright, welcome to the NUPOC video study guide number 90. Let's keep going with another pulley problem. This one has 4 pulleys instead of, I think it was 2 in the last problem. But it's really not that much more complicated. What we're asked to find is the tension in the rope, right? And also the tension in this connection that's anchoring pulley 1. And if I label these, it's like this, 2, 3, 4. That's anchoring pulley 1 to the ceiling. Alright, so let's go ahead and approach this the same way we did the last problem. By the way, this mass is moving upward at a constant velocity as we pull down on this rope right here. But there's no acceleration, so it is a statics problem. So we're just going to go ahead and we can sum forces, for example, in the y direction with all of these connections between pulleys and all of these the tensions in the different portions of the line, and we'll just sum them all in the y direction and set them equal to 0, and we'll just do that at each pulley, and that will allow us to solve for the tension in the rope and then also in the connection up here. So if we start the same way we did in the last video, let's look at the mass. And let's draw a free body diagram. So we have mg pulling it down, and we have what I'm going to call F4 pulling it up, right? Since it connects, this is the connection to pulley 4 right here. Okay, so then we can say F4 equals mg. Okay. Now let's go ahead and look at pulley 4. Okay, so at pulley 4 we have pulling down, we have F4, which we've said is mg, and we have the tension of the rope pulling up on both sides of the pulley, and we've got this connection to pulley 3 here, so let's call that F34. Okay, so we can say that 2ft plus F34 equals mg. Alright. Now we need to find out what F34 is, so let's go up to pulley 3 and do the same thing. So at pulley 3 we have F34 pulling down, and we have the rope tension, Ft, pulling up on both sides, so we have F34 equals 2 Ft. So we can go ahead and sub this in over here, and we can say 2ft plus 2ft equals mg, or ft equals mg over 4, right? So that was actually pretty quick for what seemed like, I don't know, maybe kind of a seemingly complicated pulley problem. But all we had to do is do the analysis at a couple of points, just enough to find out what the tension in the rope is and relate it to the mass. So Ft equals mg over 4. So that's pretty cool. So you have some mass here, and you put this pulley system in, and then you can raise it by only applying a quarter of the force that this block or this mass is pulling down with. So that's pretty cool. Now let's keep going so we can try to find the tension in this section right up here. Okay, so let's move up to pulley 2. Right. So at pulley 2 we have the tension of the rope pulling down in 3 places. Right. We have where the rope wraps around the pulley, and then also in the middle of pulley 2. I should be labeling these. Where the rope is anchored to the middle of pulley 2, and then pulling up we have what I'll call F12, the connection between pulley 1 and pulley 2. So we have F12 equals 3 Ft. Okay. And now let's go ahead and look at pulley 1. Right? This is pulley 1, and we have F1 pulling up, F12 pulling down, plus bit bigger, Ft and Ft, rope tension pulling down on both sides, so we can say that F1 equals F12 plus 2 Ft, and we know that F12 is 3 Ft, so we have 3 Ft plus 3 Ft plus 2 Ft equals 5 Ft. 5 Ft. And of course we know that Ft is mg over 4, so we can say that F1 equals 5/4 mg. Alright? And a way that we can kind of verify that using I guess some engineering intuition is if we look at this whole system, right, we can see that F1, right, if this whole system is being suspended, it's not falling down, right, F1 has to take the entire load of all the forces pulling down in the system, all the net forces pulling down in the system. So we have this mass mg here, so we know it at least has to be mg. If we got F1 to be less than mg, we would probably think, maybe that something's missing, right? And then if we look at the rope, right, we have one way to think about it is, we've got the rope exiting in the upward direction, sort of pulling up in 1, 2, 3, 4 places, and we have the rope exiting a pulley downward, or pulling down in 1, 2, 3, 4 places. 5 places actually, so 4 of them cancel with each other, but there's this 5th place where it pulls down where the rope is anchored, right? So that anchor, that load from the rope pulling down on pulley 2 needs to be supported by F1 as well, and we know that Ft is mg over 4, so we have to add an extra mg over 4 to mg, right? The other load pulling down, and so we get 5/4 mg. It's the mass pulling down plus the tension in the rope has to be supported by F1. So if we wanted to decrease the load slightly here in this connection, we could take right here where the rope is anchored to pulley 2 and take it and disconnect it and maybe anchor it up here to the ceiling, right? And then this would only take mg, and then the load over here on the ceiling would be 1/4 mg, right? mg over 4. The ceiling would still have to take the full load, but we could split it between 2 points. So just an interesting discussion on how to kind of intuitively go through and check, whether your different loads in your pulley system make sense. Anyways, thanks for watching, and as always, don't forget to click down here and subscribe so you don't miss the upcoming videos.